Andrew knocked my phone over. So we were rudely interrupted, but let's continue. Okay. During the break, I remembered, by the way, that to figure out with a hydrocarbon how many hydrogens there are, it's the number of carbons times 2 plus 2. So 5 times 2 is 10 plus 2 is 12. That works for all hydrocarbons. I just couldn't remember it because I was busy talking too much. Anyways, so we're burning pentane. We're figuring out the molar mass of pentane. So, I think I was in the midst of calculating when Andrew threw my phone on the ground. 5 times 12.01, oops, is 60.05 plus 12 times, oh my goodness, 1.01, there we go, 12.12. You're probably faster than me. Okay, 72.17 AMU for 1 molecule, 72.17 grams for 1 mole. Okay, so now we know the molar mass. We've got 50 grams of pentane that we're starting with, and we know that there are 72.17 grams in 1 mole. Okay, so we put grams on the bottom so we can cancel out. So what's 50 divided by 72.17? 0.69. We've got, oh no, we've only got one significant figure. So I'm going to just change this since I just made up this. Let's just say 50 point, all right. So we can have 2 significant figures. 0.69 moles of pentane. Okay, now I know how many moles of pentane I have. Now what does this equation tell me? It tells me that 1 mole of pentane reacts with 8 moles of oxygen in order to get 5 moles of carbon dioxide plus 6 moles of water. Can you see it okay on there? Yeah. Okay, so 1 mole of pentane yields, well, I want carbon dioxide, yields 5 moles of carbon dioxide. Okay, so this is a conversion factor. Now this applies only to this reaction, doesn't apply across the board, only to this, specific to this reaction. Okay, so 1 mole of pentane is 5 moles of carbon dioxide. I have 0.69 moles of pentane, and I know that, put the over 1, make it times in a fraction. I know that 1 mole of pentane yields 5 moles of carbon dioxide. Okay, so see how we can do that? Now I can cancel out moles of pentane, and I'm left with moles of carbon dioxide. So now it's 0.69 times 5. And that is 3.45, or rounding to 2 significant figures, 3.5 moles of carbon dioxide. So now I know how many moles of carbon dioxide I've made. I want to know that in grams. So let's figure out the molar mass of carbon dioxide first. Carbon is 12. I've got 1 of them. 2 oxygens, that's 16. So that's 32 plus 12.01 is 44. Right? 0.01 grams per mole. Okay, so I've got 3.5 moles CO2, and I know in 1 mole there's 44.01 grams. So I do 3.5 times 44.01, and that's 154. Since we only have 2 significant figures, I need to round that to 150 grams carbon dioxide. Okay? Where's my eraser? So that's how we can go from grams through moles back to grams. And this is something you'll do very often in chemistry. Start with grams, you have to convert to moles, figure out, with your molar ratios in your chemical equation, figure out how many moles of product you have, and then convert back to grams. Now, some of the questions might be, you produce this many grams, how many did you start with? Or you have this much pentane, how much oxygen do you need in order to combust it? So you should be able to do it in any of those iterations. Okay, we're almost done. There's several questions that are like this. I think that the rest of them are pretty straightforward. Okay, the rest of them are pretty much like this. Do you feel comfortable? Do I need to do any more questions like this? Andrew? Is that good? Do you want to do one more? How about, let's do number 18 on the chapter review. So on page 225, number 18. A chemist is using the following reaction. Boron oxide, B2O3 plus 3 magnesiums yields 3 magnesium oxide plus 2 boron. So they've already balanced it for you. He wants 125 grams of boron. How many grams of magnesium will he need? Okay, these are a bunch of chemicals we've never used before, but using our periodic table we can figure all this out. What was I going to say? Oh, this is, what type of reaction is this? So we've got boron oxide. We've kind of taken out the boron and replaced it with magnesium. This is a single displacement. Okay, so let's figure out some molar masses first. What's the molar mass of boron? It is number 5 on the periodic table. Its molar mass is 10.81 grams per mole. And then what's our molar mass of magnesium? It is number 12 on the periodic table, 24.31 grams. Okay, so I've got 125 grams of boron. So, like a lot of our chemistry problems, we're going to go from grams to moles and then back to grams. So we've got 125 grams. We write down what we know, put it over a 1, make a times and a fraction. So I know that there's 10.81 grams in 1 mole of boron. Grams cancel. Let's do 125 divided by 10.81. That is 11.56. 3 significant figures, and we're going to round to 11.6 moles of boron. Okay? Now, I know that 3 moles of magnesium give me 2 moles of boron. So I can say 3 moles magnesium equals 2 moles boron. So now I can do this, 11.6 moles boron, put over 1 times in a fraction. I know 2 moles boron give me 3 moles magnesium. Then I can cancel out moles boron, and I'm left with moles magnesium. So 11.6 times 3 divided by 2 equals 17.3. Right, 3 significant figures we're going to carry through. So now I have 17.3 moles magnesium, and I know that in 1 mole of magnesium, there's 24.31 grams. The moles cancel out, we're left with grams of magnesium. 17.3 times 24.31. We get 421.6. We got to round to 422 grams magnesium. So that's how much I need. This chemist needs to use 422 grams of magnesium in order to yield 125 grams of boron. All right. Call me, email me, text me with any questions. I'll be happy to answer any questions whenever you have them. So, test is due Tuesday, along with your lab books. Thank you.